Here's a summertime northwest flow setup, August 18th, 2011, near Ewing, Nebraska, towards the north central part of the state. You can see here your 500 millibar map. There's a trough up here, but it's mostly just flat zonal type flow. There's not a big ridge where if you had a big bulging ridge, you would have more, capping concerns probably. So it's kind of flat. Your heights are all flat. They're not bulging north and rising anywhere, these lines. And we had a warm front going up through here. And see here your northwest winds about 40 knots, the mid levels at 500 millibars. So you had enough flow up there to give things a chance. Like if that was 20 knots, then you probably need your storm to anchor on a boundary and go southwest. I've had that happen a couple times where the storm goes deviant way against the flow. It anchors on a boundary, and since there's such little flow, it's not really blowing along. It can kind of propagate down the boundary it's on towards moisture like a dry line or surface trough, which is also out here you'll see on surface. But since this warm front was running this way and you had your winds running that way, it could kind of ride the warm front, and then if you had any low level flow, it would help the storm. And then up aloft there was some flow. It wasn't real strong either, but usually summertime storms are like this. But you did have a sharp, nice warm front. In summer, there aren't a lot of setups anyway. So anyway, this turned out to be a good little chase with a tornado. Tornado's probably right in here. I'll switch to the 850 millibar. You can see rich moisture, 20 Celsius dew point is crazy. And really good low level moisture. And it's not real strong flow. Omaha 20 knots from the south. So you had some southerly flow at about 6,000 feet. And your surface flow is like southeast. And then remember that mid-level flow is from the west-northwest. And also I'll say this, on these northwest flow setups, you got to be careful. In any setup, you don't want too much turning. Because if your storm is northwest flow and then you had southeast surface winds, the storm would be kind of blowing all its rain into its inflow, and they just really don't ever work. They get pulsy because they pop up and they kill themselves with their own precip that they ingest back into themselves. So you don't want too much turning. This is a good bit of turning where it's, southeast and your winds were west-northwest. That's okay. Even less than that's probably better, but not a whole lot to see at 300 millibar. Well, there's strong flow out here, but it's kind of weaker right in here. It might be a decent. It can drop off fast on some setups, obviously, because that's at least 75 knots right there, and then you're down to 40 knots at Omaha. So there was some flow at 300 millibar, kind of help vent the storms, especially if they move slower. The slower they move, in the storm relative sense aloft, that's going to be better flow. Whereas if that storm goes forward quickly, that flow aloft's going to be weaker in a storm relative sense. Here's a 700 millibar map in the morning, and these temperatures aren't too crazy for middle August. So the cap was definitely breakable, especially out here. Yeah, 13C at Rapid City, 13C at North Platte, 10C in Omaha. But then as the day goes on, you can see they don't move a whole lot. 15C down there. Omaha's got storms over it now. 11 Rapid City, but you can watch these lines of the temperatures, the red lines. You can watch how they don't really move from morning there to evening. So your cap probably wasn't building or nothing. Then your low levels were still feeding up underneath there and getting full sunshine on them. The cap just broke from below heating and wasn't getting any worse. Here's the 5 p.m. surface map. You can see how you got these south winds out here bumping into these southeast winds and even east up here in O'Neill. And then there's a thunderstorm marker there, and then these clouds, these obs are showing clouds over these stations. Quarter cloudy there, full sunny, full cloud, clear. Anyway, there's storms tracking over this area, and those are really reinforcing that boundary, that warm front and outflow boundary now. You can see it on the surface winds too. They kind of turn. You have that west-northwest mid-level flow going like this, and then these southeast flows. Not too much turning, but it's pretty close. Then the low-level flow off the deck towards 850 millibars from the south more. So it's a pretty good setup. And then out here you can see southwest winds, west, west, northwest. And it's hot. Look how hot it is, 98, 99. But anyway, you can tell by here there's probably a surface trough going right through here where this wind switched. It's still 66 dew point, 71 dew point out there. That's really high. 72 up in O'Neill's high. Temp only 81. Even 91 over 71 ain't too bad. Compared to behind this boundary, your dew points are dropping off, and they plummet out here, obviously. But anyway, the convergence was right here, and you could see it on, I think you could see it on North Platte's radar. I don't remember, but you could see the boundary out here, and then that dry line. And it was kind of hard to tell how far west to be on it because there were some clouds out there. But really, it doesn't. It's not too hard. You just get out in the general area and then watch how things unfold. And it forms right on that boundary and then pretty much right where the dry line intersects it. And this can be such a favored area for that type of setup to work. I swear, you could have the same setup over here in eastern Nebraska and it would never work out in tornado. But this zone out in here, especially summer and even up into here, it's just perfect. They're going to happen. They're going to happen out here. Here's a satellite that morning, and not a whole lot to tell yet. Other than that, it's very sunny out. Not any real cloud issues. And I'll step it forward here. See, now you're starting to get some thunderstorms popping up here. But the environment, the air was a little cooler, so I figured they're going to be elevated, and that happens quite often. Early day storms tend to be elevated. Not always the case, but a lot of setups, that's how it works. And your boundary was in here, so they were north of it, elevated. So I just drove on by, even as they got severe warned. They got a pretty nice look on a radar. Probably would have been worth chasing eventually. But my target was out here later, so just kind of ignore some stuff and it pays off. Just a big storm now. See this boundary, the boundary of target is here, and you'll see some north-south boundaries showing up for like the dry line, the trough out here. And now it's getting interesting. Here's a boundary. Hard to see where the other one is. And you start to get the north-south extension. You end up just kind of, there ended up being two ideas. You weren't sure if it was going to fire on the western edge of the cumulus cloud or on this area to the east. Probably a little deeper moisture, and sometimes storms just pop up east of the dry line trough on the boundary, and those can be better. There's the west edge, but it's out there ways. O'Neill's over here. And this storm fires near O'Neill, around on O'Neill, and then it goes southeast towards Ewing. See, now if you went out here for this, thinking your target's out here on the western edge of the moisture and the cumulus clouds that are trying to go, you'd be like, ah, crap, I need to get back to the east because these are popping. Two of them pop. I stayed to the east because I figured you could always move west pretty easy if you need to be. Harder to catch back up from the west if the storms are going away. And then notice all over in here, big storms. It's just and this one that goes through like Council Bluffs is a very severe hailstorm, busting windows out of cars. Thing was insane. That one's probably good too, but they were more elevated in nature. This one probably wasn't by then. It was firing closer to that boundary that these are on. You'll see that on radar. Now there's two supercells up here right on that boundary, and those Q died out further west. You can see this supercell comes in almost, it'll kind of run into this one eventually, but this one tornadoes before it does, and this one never really was that great. And you knew if you were there, that one would eventually die anyway because this one was in its inflow. That thing would start sucking on the garbage air this was spitting out. And that is a pretty big supercell that turns even more south on here. You'll see on radar. Here's the radar at 3:30. I'm already out basically under this when it fires near O'Neill. And these I passed up on the way out there. I think it was over here. Maybe it's a different one. I passed up one that was north of Norfolk early on my way out. So this is probably another one that was tracking through there. But this was my target where the dry line out here intersected this boundary. You know, watch how this unfolds. And there'll be one fire here. I live like right there. So it's kind of annoying that one of the days I'm not home, a crazy hail producer goes just south of town. It just flattened the corn and shredded houses. I mean, baseball-sized hail, and a lot of it. It formed just south of town and went right into Council Bluffs or near Council Bluffs. So I wouldn't have minded being home that day, but at least I saw a tornado out here, so not so annoying. But anyway, you can watch this unfold a little bit. See how that one back near home's on the boundary too, and it's got a little hook already. This one's kind of north of the boundary already, and this one's going to try and fire on it. Kind of two of them right here, probably. Yeah, that thing's going right into home. Here's my storm. I'm out here. I'm about under it right now. I'm coming back. I was on the highway south of O'Neill, and then I went back up and over and down the southeast highway. The thing went right down the northwest southeast highway. And that thing looks good on radar too. Probably a big time hailer. And it's probably elevated, but it could have been getting lower by now. This air heats a little. I don't remember what the temperatures were, but it could have been slightly elevated. Now that one's nasty. This one's going kind of cycling a little bit because it didn't do anything in town. Just once it gets by here, it goes crazy. And mine's getting a better core on it now. And the thing about some storms, when the shear and the setup is just almost good, but not quite, they can tend to have two entities to them. You can get a back portion of the storm want to be a base, and you can have a base trying to take over in the front of it. And you'll see on this chase, this happens. And if you have a front area that rotates and then your back area is rotating, they screw with each other. You can't ever get one of them to decide to take over. And what happens is that front area finally lets up spinning enough to let this back thing continue to spin, and it finally produces a tornado. You'll see it on the video. Kind of hard to see it on radar, the two entities sometimes. You can almost see there now. See, it's kind of two storms. And it'll keep doing that. This one even was doing that. And now that thing's producing crazy hail just south of town, just north of Omaha. Really bad hail now. But now look at that. The first one kind of dying off, and then the back one tries. And it's going to produce a tornado pretty soon. See how that happened? And then the back one starts to take over again. In about 20 minutes from now, it's doing a tornado on this back part. Starting to do one now. And it's like, you can watch it on video. It's like this part let up spinning enough to let the back base spin. It's kind of an elongated base, but it was trying to spin. Now you can see the hook on that back part. That's where the tornado is happening. Just southeast of Ewing. And this other one's about to run into it. But you can watch another one will form, and it'll get a hook too real quickly. And sharp, look at this sharp outflow off this storm now. That outflow off the storm is just reinforcing that boundary. And you'll get cells that lift. They form as this pushes air and rises the air. They fire off north of the boundary, above it, elevated. And now it's getting kind of messy, and you get another one fires up right in front of it. I remember right, this tornado's, yeah, we had some weird funnel action. I'm not sure if I got it on video or not. We'll see, but you see how that hooks right away. It fired up, and that thing tried to go crazy right away. And we had just went southeast because this was starting to rain on the highway, and we were losing our view back into the hook. We had to go southeast to go south at Neely. And you see all these storms firing now north of that boundary, and this thing's still going kind of crazy down there. And sometimes when they're big like that and they got big hail cores, you can usually count on them being HP hail producers that are just so outflow driven they probably aren't tornado producers. Not all the time, but generalization there. So you got two entities again, and this one will take over this time eventually. Actually, the back came forward, and then it'll turn south. Look at that. I couldn't believe that when it was happening. I was trying to get back in front of it. I was stuck right behind that. And you can see the whole thing just rotating from behind. You'll see that on video probably. And I don't think it ever did tornado, but it was trying. Now, then eventually you get a big, this is like the beginning of a big complex in MCS. It'll plow further as a big organized huge system. That one going. So much going on here. And even it's the best point right there, and it didn't do the most. It did the most back here, just before that. Yeah, that elevated one don't have a chance. It was going this way. It needs to go this way, because if it's going this way and think of that flow of loft's blowing this way, and that storm's elevated and it's going that way. Even if it was low, any of the inflow raining into it, raining this way as it goes this way, but then the inflow is this way. It just doesn't work if it's going left of the flow of loft, because that was clearly going left of the flow of loft. That needs to go with the flow of loft and to the right, like the mid-level flow. Otherwise, it acts like what's called a left split, and they tend to have their base on the opposite side then, and they're just kind of, they don't get organized typically. So you want it to go right of that mid-level flow.